This topic is dear to my heart for a couple reasons. One is I love science. I love the history of science. And luckily, my career got me into an area of cell biology called cell culture, which led me to look at polio vaccines from a different point of view. But I'm not really going to be talking about the cell culture part of this today. What I really want to talk about is how we got to where we are today with the polio vaccine. And it brings back memories of when I was a kid. I grew up in New York City in the 1950s. I clearly remember the fear of the polio epidemics. I had both a great aunt and a sister-in-law that were lame, where they had partially paralyzed legs. They could walk, but because of the paralysis, one leg didn't develop during childhood as much as the other, so creating problems. I remember my mother telling me that I couldn't go near the park sprinkling system they had in the summer, couldn't go in any swimming pools. And I remember when they finally decided I had to have my tonsils out, that I couldn't do it during the summer because that meant going in a hospital filled with kids with polio. I had to do it during my Christmas vacation, which was a real bummer. Finally, in 1956, I got the vaccine when it became more widely available. It was 3 shots. In 1964, I again got the vaccine. This time it was on a sugar cube. It was a different form of the vaccine. And I've avoided polio, so I guess the vaccines really worked. Okay. So today, I really want to talk about why polio became one of the first diseases to really get this kind of treatment. I also want to look at how the battle was fought to develop the vaccine, the key players. Some very interesting characters are involved in this. And not all of them were very nice, but what they did accomplish changed our world. And I'm assuming some of you may have memories of this as well, the polio time. There was more to it, and that is, up until the 1900s, sanitation in cities was horrible. And so everyone was exposed to polio repeatedly. The majority of people would be exposed to it shortly after birth. Their mother would usually be breastfeeding, and she could pass antibodies to polio through the milk. She also passed them through the placenta. So the chance was excellent that the baby would have some antibodies, not necessarily a lot. The mother would have a lot because she was exposed to it every day. And so it was like getting a booster shot daily. And once they cleaned up the sanitation, you didn't have the outbreaks as frequently. So years could go by in a city where there'd be no polio. Now you had kids that were 4, 5, 6, that their mother's antibodies were long gone, and they hadn't been exposed to polio. And so when the polio epidemic broke out, it could spread quickly. And polio is spread primarily fecally. In other words, somehow the water system, like the Charles River, where they were getting water from, all of the towns upstream were dumping the poop in, and you ended up having epidemics. Not very pleasant to think about, but it was a real problem. So the problem got worse and worse during the 1900s as the cities got cleaner and cleaner.
But the water got more and more fecally infested?
No, it was less.
Yeah.
But if one kid got it, He could infect an entire river. But it wasn't just fecally, because if the kids, go to the bathroom, they don't wash their hands, it gets on food, it goes quickly through food. It can also go by close contact. And so, if one person in a family got it, it was common for the rest of the people in the family to get it. In 1952, there was a very large epidemic in the United States. There were about 57,000 people affected. Of that, and I'll talk about this a little bit more, but later, about 21,000 of those were paralyzed to some degree or another. If the paralysis affected your breathing muscles, your diaphragm, you could no longer breathe. And most people under those conditions would die. And so in that summer of 52, there were about 3,000 dead. That sounds like a lot, especially when it's children. But we were seeing 3,000 people dead just 4 years ago, a day. And so in the scheme of things, that's not what makes polio so scary. So really, it's a 20th century problem. Oh, let me just talk a little bit about the polio viruses. So the polio virus is one of the smallest viruses known. The only viruses that are smaller are parvoviruses, which cause heart problems in dogs. And so you can see the relative size. This is the COVID virus, polio virus, HIV, influenza. That's an E. coli. That's a bacterium in your intestines that everyone has. That's a human red blood cell. So the diameter of one of your hairs is about 6 times wider than the diameter of a red blood cell. And so we're talking pretty small. You can't see viruses through the microscope. They're way too small. But using an electron microscope, you can see them, and they basically look like that. So when that gets into your mouth, goes down to your intestines, it begins to attack the intestinal lining cells. And so when a virus attacks a cell, it attaches itself and injects its DNA and makes new viruses. And so about 95% of the people that end up with the virus in their stomachs or intestines, they may not even have any symptoms at all. It may irritate a little bit, but unless it gets into the bloodstream, there's no problem. Sometimes people will, like have a 24-hour virus. We used to get those all the time as a kid. Never knew what they were, but you'd be sick for a day. You got home to watch TV, and you had to have tea and toast. So it really wasn't a big problem for the majority of people. They didn't know they had it. But for about 5% of the people, it gets into the bloodstream, and it gets into the muscles, and it gets into other tissues, the tonsils being one of them, and it makes you feel lousy. So it's like a bad cold or a case of the flu. Less than 1% of the people, it gets into the nerve cells. Once it's in nerve cells, it's very hard for antibodies to do anything. They can't really get in to protect the nerves very well. And it will start killing nerve cells, and that leads to paralysis. If you're younger, you may have enough nerve cells, baby nerve cells if you wish, that you may be able to repair it and recover from the paralysis. But a percentage of those that are paralyzed, maybe 10%, depends a lot on the conditions. There's no surviving it. And so it is a very small virus. And of that 1%, that's called paralytic polio. That's the one that really is the scary one. So the way a virus infects the cell is relatively simple. You have the virus particle. Basically, it's a little cup of protein containing inside a nucleic acid, the genes of the virus. In our body, in the nucleus, we have DNA is the genes, makes up the genes. In this particular virus, it's RNA. In our bodies, our DNA makes a copy of itself called mRNA, and it sends that out of the nucleus, and it makes a protein out of that. This virus basically is already an mRNA. And so when this virus particle attaches, it just injects the RNA, and the RNA gets into the cell. It then takes over the cell's machinery. It then makes copies of the proteins that it's made out of and copies of its own RNA. And it does it very quickly. In 3 or 4 hours, a cell would be completely filled with 10,000 viruses, and at that point the cell would burst and the viruses spread. And so the infection happens quickly. There were reports in the 1920 flu epidemic of people getting up in the morning and feeling fine, going to work and dropping dead on the way home. That was a viral infection. Whereas these can multiply to that degree in 3-4 hours, bacteria may only increase 4-fold or 5-fold in that length of time. So it's very, very, very fast. It was a very frightening disease, and you can see from the pictures, no one wants to see young children crippled. TV wasn't available in the 20s, 30s, and 40s, but in the early 1950s, it started. And now I still remember our TV. The TV was pretty big, but the screen was about that big. And, but you saw pictures like that. And so it was really scary because it really affected the young more than the old. At least 5 to 10% of the young paralytic victims of polio died. Older people, adults, it was often very worse, much worse. When it paralyzed the breathing muscles, that's when you ran into the most serious problems. Here we have iron lungs set up in a Boston hospital. These are a model dating to 1955. They're much better than what they had when they were developed in 1938. They were actually invented here in Boston in 1927. It was a group at Harvard that developed the first ones. They were clunky and expensive. By expensive, they were about $2,000. You could buy 2 houses back then for $2,000. It was improved in 1930 to something more resembling this, and the price dropped all the way down to $1,500. And they needed, when they had epidemics, they always needed more of these than they had. Some people would go into them and, they would be in them for a week, 2 weeks, and their muscles would recover enough that they could come out. Other people were not so lucky. Also, it was very contagious, and in 1934, at a hospital in Los Angeles, 5% of the doctors working in the hospital and 11% of the nurses came down with polio from working with the polio patients. So even though you were masked and very careful about washing, it was highly contagious in close quarters. And this was not through the fecal route. This was just from contact, although I'm sure there was a little bit of the other kind of contact too. And one thing to keep in mind is, in a year where 3,000 people died from polio, there were probably 10 to 20,000 people that died from the flu. So it wasn't like it was the worst disease out there, but it was very, very visible. The other problem was, how do you treat the disease? And that's a serious issue because there are no medications back then or now that would help. Nothing you could really do. And so there was a nurse in Australia that developed what her name was Sister Kenny, and her method was hot compresses and massage. People that had mild muscle damage sometimes would regain the control of their cells. It just depended upon how much damage was done, how old you were, and how good your body could recover. People also found hydrotherapy to be very, very, very helpful. My wife told me when she was a kid growing up in Hong Kong, her sister came down with polio and had mild leg paralysis. And her mother used to throw coins across the room for her to go get, to help her constantly move the muscles. Because once you stop moving the muscles, even if you're not moving them yourself, someone is doing it for you, they atrophy. And once they atrophy, they stop growing. And so you need to find some way of doing this type of work. So there really were no treatments. And again, as we talked about before, if you needed the iron lungs, this was Haynes Memorial Hospital again, it was really tough. Have any of you ever seen one of these in person? There's a bed on a sled inside. The person's head sticks out. And they can be slid in and out. And there are ports so the nurses and doctors can go in. Essentially, it's a vacuum chamber for here down. Your head sticks out. And when they inflate, it pushes and the air comes out. And when it deflates, it sucks and your lungs expand and pulls the air in. Often people would be in those and they could come out for 5 or 10 minutes a day, or depending upon how severe it was. Other people, if they came out, they died. Interestingly enough, in 1959, the polio epidemic was pretty much over, but 1,200 people in the US were still using iron lungs. And in 2004, there were still 39 people using iron lungs. One of the longest users, Paul Alexander, died last year. He spent 70 years in the iron lung. He became a lawyer and practiced law, all from while he was in an iron lung. There is still one woman, she's still alive, that uses an iron lung at night. During the day, she can, keep it going, and she's been in it about 70 years as well. So not something you really want to think about, but it was pretty scary.
And they couldn't just take the polio vaccine while they're in the iron lung?
But it was too late. The damage was done.
Oh, that's the issue. Okay.
So they were paralyzed from the polio. And there was, literally people died waiting to get into one. And there was a polio outbreak in Copenhagen where they called on all the medical students and nurses in the city to come in the hospital and help people breathe using a bag. And they had to work in 3 8-hour shifts. And they did that for months to keep the patients alive. So FDR came down with polio in 1921. He was a very, very active man. He was 39. He was at Campobello, an island belongs to Canada off the north coast of Maine. He was on vacation and he developed the typical symptoms of the flu, sore throat, quickly progressed, and he ended up paralyzed basically from the neck down. So his arms, his hands, his internal organs, his legs were paralyzed. Luckily for him, his breathing was not. So they sent him home, and he spent a year undergoing intensive therapy at home. A lot of it was massage. And basically, he got back all of his abilities except his legs and lower abdomen. In 1924, he went to an old inn, Meriwether Inn, in Warm Springs, Georgia, that had a warm spring literally attached to it that went into a pool. The water was 88 degrees, and it had high levels of calcium and I think magnesium in them, which increased the density of the water. In that water, he could stand. It also, the ability to stand, relieved a lot of the muscles that were still good. So he was very, very, very comfortable. Unfortunately, this place was falling apart, and it was sold right before he got there. A couple years went by, he kept coming. It had changed hands, and he ended up buying it. And he bought it in 1926. He paid $200,000 for it. It was a lot of money, and it was 2/3 of his fortune. He was not a really rich man. But $200,000 back then was a lot of money. And so that's what the house, the inn looked like. There were tennis courts, there were a lot of other things on it in the place. But he really, really liked the place, and so he bought it. Unfortunately, it needed funds to make it better. He didn't buy it just for himself. He invited polio victims that needed rehabilitation to come there, and they did. And so he had the problem now, once polio patients are going to a hot spring, normal healthy people are not. They don't want any part of it. And so he had to figure out a way to pay for all the improvements. He just didn't have the money. He turned to a guy by the name of Basil O'Connor, and we'll see a lot of him in this story. Basil O'Connor had been his law partner in New York City, corporate law. Roosevelt and O'Connor was the name of the group. He was from Taunton, Massachusetts. Like Roosevelt, he went to Harvard Law. And so he became very, very good friends with FDR. And he came up with the idea of turning the resort into a nonprofit, because then they could go to their rich buddies and friends and other organizations and try to raise money. And that's what they did. Became the Georgia Warm Springs Foundation. And so they started in 1928 to make a lot of changes and improvements. But then in 1929, what happened? And so all his rich friends weren't so rich anymore, and they slowly but surely started running out of money. And so they had to come up with another solution. And again, his buddy really came up with the perfect solution, and that was starting not just a foundation, but now starting birthday parties for the president. Because in 1928, he became governor of New York State. He was governor for 2 terms. In 1932, he ran for the presidency, and he won that. And so he needed to really find a good way to make money. And so they started on the president's birthday what were called the President's Birthday Balls. And they would have this all over the place. And they raised a lot of money. In the first year, they raised $1 million with 4,376 communities running balls at 600 separate celebrations. And so they would charge people a small amount to come to these, and they would ask for donations. These fundraisers continued until 1944, and they probably would have continued longer, but FDR died. And they allowed for the building of really beautiful swimming pools, a motel for people. They tore down the old one. They put in a really good rehabilitation hospital, and they've been helping people ever since. But he wanted to do more than just help people with their medical problems. He wanted to stop polio. And so to do that, he realized they needed a vaccine. So again, and this is Basil O'Connor here with the president, and you can see a lot of dimes. You've all heard, I'm sure, of the March of Dimes. Eddie Cantor, who was a famous Hollywood star, was the one that came up with it. At that time, in the movie theaters, they used to have a newsreel called The March of Time. And he changed it to The March of Dimes. And they asked kids and people to send in dimes. And so they set up the March of Dimes. It was then called the National Foundation for Infantile Paralysis. March of Dimes does sound a little better. And to, as Roosevelt said, to lead, direct, and unify the fight of every phase of this illness, which is what he then set out to do. The first year, they raised $1.8 million in dimes. And this is what the first day when the letters started pouring in looked like. It shut down the postal system in DC. And just dimes. I mean, it cost 3 cents then to send a letter. So it was really a 13-cent donation, unless I guess you could tape it to a postcard maybe for 2 cents, penny, or I forget what it was, but it wasn't much. And by 1955, they raised over $233 million, which today would be the equivalent of many billions of dollars. I mean, it's really, really incredible. So now they had the money and they could start to work on a vaccine. So what is a vaccine? A vaccine is simply something you can inject into people. Usually it's bacteria or viruses that are weakened or dead. And you inject them into a patient. That activates the patient's immune system. The white blood cells recognize the foreign nature of the bacteria, the virus, primarily the proteins. And they start to make antibodies that recognize and stick to those proteins. And that triggers a whole cascade of other cells coming to gobble them up. And so it's your basically the best immune system you can have. But it takes time for this process here to build up enough to stop. And when you're fighting a virus that can multiply so rapidly, there's not enough time to do it. The good news, though, is these cells in the immune system have a memory. They remember very clearly what the antibody looked like. And so now they know what the antigen, the bacteria looked like, or the virus looked like. So now they're primed. It's like having reserve troops. They're there. They're just waiting for the signal. And because they're there, they can react very quickly, and it protects you from future problems. So, but the trick is, you have to have weak or dead bacteria or viruses. So that's the hard part, especially back then. And the reason was, how do you grow a virus? Viruses are very unique organisms. Many people don't consider them living. They have 10 proteins. They have a piece of RNA that is the genetic material, and that's it. But some of those proteins have the ability to recognize a spot on the wall of certain cells that allows it, it's like it's a key. It allows it to lock on and get into the cell, and then it just takes over and really runs amok. Poliovirus will affect monkeys, some other primates, but it doesn't infect anything else. So it's very, very specific besides people. John Enders was a cell biologist and virologist that was trying to grow viruses. The way they used to grow them was you would inject them into the brains of newborn mice, and sometimes they would grow a little bit. The brain is protected from the mouse's immune system, and if you were lucky, you got more viruses out than you put in. But you couldn't see them. It was very, very hard to do any work with something you can't see. But using cell culture, he was able to grow some viruses. He grew the measles virus and the mumps virus. And so he was working with those in the 1940s. He had a couple colleagues that worked with him, younger scientists that were there on training grants. And they had set up a bunch of cultures using human fetal cells from a fetus that was aborted. I don't know whether it was aborted medically, intentionally, what the story was. But it was, and it was a very young fetus, like 11 weeks. And he was able to grow the mumps virus and the other measles virus on those cells. He had a couple cultures of cells that weren't used. And one of his helpers said, "We have some polio virus, why don't we try it?" And it worked. It worked very, very, very well. And that work was done at Children's Hospital in Boston. So again, Boston was really playing a role in this. So now polio research moved from trying to do it in animals to doing it in cell cultures in the laboratory. And this was a big step forward, because if you can grow the virus, you can weaken it or kill it and then make a vaccine from it. So in 1951, Jonas Salk, who was also a virologist, he decided to take the technique that Enders had developed. He grew up virus using media from another organization that helped the cells grow very well. And he killed it using formaldehyde. So he thought he had a vaccine. And so he did a little bit of testing in some monkeys. But back then, before you test vaccine on people, you inoculate yourself. If you're there the next day, you inoculate your family and your coworkers. That was the system. There are more than a few famous scientists that died that way. And so he took the risks. That's his wife and his son. I mean, that smile on her face looks just a little bit forced. After he inoculated his kids, he then went to a hospital that served polio victims, children, and they had already had polio. They already had antibodies. He could measure the antibodies they had, so he gave them the vaccine to see whether it would increase the antibodies. It wasn't going to give them the disease, but it worked. He then went to a home for mentally disabled children and basically used them as the next round of guinea pigs. In this case, they got the vaccine. None of them died. And so once they'd done that, it worked, and they were ready to go big time. And going big time in this case meant now you have to grow a lot of virus because you're going to have to test it. Earlier in the 1930s, a couple researchers developed polio vaccines. And they tested them on unwitting children without even getting permission from the government, on kids in hospitals. And some of the kids died. And so that was a big scandal. One of the people, he was a fairly well-known scientist, he died shortly thereafter. And it's believed he, probably killed himself because he felt so bad. What those scientists didn't know was there are 3 different polio viruses. You have to make 3 separate vaccines. By the time Jonas Salk did his work, they knew. So there's type 1, type 2, type 3. Salk isolated all 3, and he killed all 3 to get his vaccine. Today, type 2 no longer exists anyplace. Type 3, they don't think exists anyplace, but type 1 is still around, and it's still infecting people in Afghanistan and Pakistan. So in order to grow a lot of virus, they had to go to an institute called Connaught Medical Research Lab in Toronto. They couldn't do it here in the United States. These guys were the experts. You've probably never heard of that company. It's now owned by Sanofi, but this is where they invented or discovered insulin, and where they made the first insulin and used it in the 1920s and 30s to help diabetics. That was a Nobel Prize winning discovery, and they deserved every bit of it. They were pretty good at growing bacteria to make vaccines. And so Arthur Franklin, he developed a culture medium. Basically, a culture medium is everything a cell needs to live. The vitamins, the amino acids, everything. And that's what you use to feed cells when you grow them in culture, in bottles. And you can see she is growing them in bottles. The cells grow on the bottom, they lay on their side. Her contribution was she found out that by rocking the cell cultures, they would grow much better and they would produce a lot more virus. And those 2 discoveries allowed them to produce about 800 gallons of media containing virus. And this was enough virus to do the trials that needed to be done in order to prove that this was something that was safe and that it worked. More importantly, it needed to be safe, because if the vaccine started killing people, that was the end.
Do they test it on volunteers? How do they know it was safe?
Well, we'll get there. They did test it on monkeys first. They used for this rhesus monkeys. And the rhesus monkeys are sort of the unsung heroes of this story. 2 kidneys from a rhesus monkey put into those bottles, minced up and grown in those bottles, would make enough cells to create virus for 65 doses of vaccine. These monkeys were also used to test the vaccines, the safety and the efficiency. They were also used in research. It took 100,000 of these monkeys to make the first vaccines. Today, those monkeys sell for between $3,000 and $5,000 a piece, if you can get them. The market right now is in China, and I believe they've increased the price to $35,000 to $40,000 a piece. Not many people are using monkeys anymore. Fortunately, we now don't need to use the monkeys. We can grow them in cells that do not require any animals. So they played a very, very big and important role. So where do you test them? Well, what you do is you round up 1,600,000 kids, and you say, would you like to help us? And that's exactly what the National Foundation for Infantile Paralysis did. And it was a high-risk operation. It was very controversial. They took 1.6 million kids in the first 3 grades of school from all over the country. 433,000 received the vaccine. 210,000 received a placebo, which was just the medium that was used to grow the cells. Another million got nothing, but they were followed closely for a year to see if any of them, what percentage got polio. And so if 5% of them got polio and the kids that got the placebo had 5% polio, and the kids that got the actual shot had 1% or 0.5%. They knew it worked. Also, of the kids that actually got the shot, 40,000 of them had follow-up blood work done to see if the antibodies in their blood could kill poliovirus. That was a big operation as well. A guy by the name of Dr. Thomas Francis from University of Michigan designed and did this. He had 150,000 volunteers from 1,500 schools and 44 departments of health. While this was happening, and we see this a lot now, a lot of scientists said it wasn't going to work, including some rather famous scientists. Sabin was the big one. Sabin also was trying to develop a vaccine, but Salk was beating him. Sabin was a much older, much more prestigious scientist. He called Salk a technician. Sabin also said in the 1930s, and he was the big guru, that you couldn't possibly grow poliovirus except in the brain tissue of humans. And so he sort of put the kibosh on the work until Enders in his group said, you know, you're wrong. And so the trial cost the government, cost NFIP $7.5 million to run. No money was provided by the government or the drug industry. It was all March of Dimes money. Each child that received a shot, received one of these cards. Have any of you ever seen them? I gave a talk on this topic about 4 years ago, and a woman came up from the audience and showed me her card. She still carried it with her. She lives in Hudson, and she remembered this quite well also. I mean, these kids were really the heroes of this story. And the parents were incredibly brave. They agreed. While this was happening, Sabin is telling the papers that this is going to kill all the kids. Walter Winchell, you've probably heard of him, he was perhaps the most popular radio announcer. Well, he ran an operation a little bit like Fox News. He said that the government had filled warehouses across the country with tiny coffins because this was going to kill all of the children. And a lot of parents pulled out of this as a result. The good news, of course, is it worked. On the 10th anniversary of Roosevelt's death, Thomas Francis had a big meeting and reported the results, and it definitely worked. It was 80 to 90% effective against paralytic polio, and it was safe. That was a really big deal. So this shows you what the long-term reaction was. By 1961, there was a 96% reduction in polio cases. This shows you how many paralytic cases. This shows how many total cases there were. And so the Salk's vaccine was introduced here. It really didn't take hold until here, but you can see by this time it was causing a landslide in the number of deaths. And so today it's really no longer a problem. It's estimated that 18 million people worldwide have been saved from paralysis by this vaccine. By 1962, 400 million doses of Salk's vaccine had been administered in the United States. The last case of wild polio in the US was in 1979. In 2017, there were only 17 cases in the world.
Question. Is the polio virus still around, or has the vaccines eliminated the virus being reproduced and distributed?
I use the word wild poliovirus. Okay? Our friend Sabin was hard at work claiming that the vaccine, even though this was the result, that the vaccine really didn't work. He introduced a vaccine in 1961. It was a live vaccine. The virus was weakened and changed. It could still divide in the intestine, but it couldn't go further than that. And it didn't cause illness. But you were infected, but only in your intestine.
The oral vaccine, wasn't it?
The oral vaccine. That was, he developed it, but we had the Salk vaccine. So he took it to Russia at the height of the Cold War and talked them into using it. And it worked. It has an advantage, especially in third world countries, because when you get vaccinated, you shed the vaccine virus, still weakened, in your feces. And so you can actually infect the people around you with the vaccine. And so in the rest of the world, it became the way of doing this, especially third world. In the United States, there was still this fear of the killed vaccine not being killed at times. And so they reintroduced that here, I think in 1964, and they basically stopped the Salk vaccine at that point. The problem with a weakened vaccine is sometimes it mutates and it's no longer weakened. Most of the polio cases that occur in the rest of the world outside of Afghanistan and Pakistan are caused by the vaccine. There aren't a lot of them, but they happen. The last case in this country was, I think, 2 years ago, north of New York City in Rockland County. A traveler from outside the United States had received the vaccine, came here and transmitted it, I believe, to one person. But the way they test to see if vaccine is circulating in a community is they test the sewerage, and it's there. So the only thing that's really stopping it from getting worse is so many people are vaccinated, it can't spread. So there might be one individual that's doing that. So this was a really big breakthrough. Unfortunately, the battle's not over, because if people stop vaccinating, it's coming, this may not come back in the United States, but measles is, and measles is a nasty critter. So what I'd like to do in the little bit of time remaining is I'd like to just talk a little bit about the people that made this happen.
Children in the US now?
Pardon?
Children in the United States now, do they get polio vaccination?
Do we still get
Is it still being given?
No, I don't believe it is. I don't think so.
The school kids, you talk about school kids?
Yeah,
No.
it would be, I don't think it is, because they've only had that, that one, but they may have to start to in order to keep it down, and time will tell. So O'Connor's is one of my heroes in this, because as Scientific American wrote, he created this system of foundations, the foundation in Warm Springs and the March of Dimes, both of which still exist to this day. From 1938 until the approval of the polio vaccine, the March of Dimes, through him, he ran it, and he wasn't paid for it. He ran it, and they made $233 million. He was the real general of the war, because he made everything happen. He decided who was going to get the money to work on this. And although a lot of money went for the vaccine and the research, a lot more money went to help people that already had the disease. He was also chairman of the American Red Cross from 1944 to 1950, and he died in 1972. He was still working for the Warm Springs Foundation and the March of Dimes. So it was really pretty incredible. So this is the March of Dimes then and now. This was a poster from the Korean War era. At that point, the vaccine wasn't ready, so they were, trying to keep them playing. Today, it's called the March of Dimes, and it's still around. They've had some problems trying to figure out what it was since they wiped out polio. What do we do next kind of thing? And but now they're focusing on babies, maternal health. For a long time, it was birth defects. So they're still operating. In 1953, the March of Dimes spent 25 times more money than NIH, the National Institutes of Health, to help polio. It took $67 million in 1954 to make enough vaccine to do the field trials. So it was an enormous amount of money. They raised it all. The foundation in 1972 was still funding rehab centers for about 200,000 polio victims. They really did a great job. Became the March of Dimes in 2007. Another hero is John Enders and his team, Thomas Weller and Frederick Robbins. They got the Nobel Prize in 1954, before the vaccine was done, because their discovery of how to grow viruses, not just polio, but measles and mumps, was considered a huge breakthrough. The Nobel Foundation only wanted to give it to John Enders, and he refused it. He said, my team deserves it every bit as much as I do. The Nobel Foundation has always had a problem with sharing it. They always felt that, if there was a minor co-partner, especially if it was a woman, nothing. And but he held on, and he forced them to do it. And that's actually the back of the one. Whoops, that's the back of the one he got, right there. That's the front. Very, very great men, the three of them. Very, very noble. And then there is Jonas Salk. Jonas Salk became very famous in 1955. Everyone breathed a big sigh of relief. He got the Congressional Gold Medal. This was him on the cover of Time in 1954. Basically, this was before they knew it was safe, but he was a polio fighter. He also got the Presidential Medal of Freedom. In 1955, when it announced that the vaccine worked, he got up on the platform and thanked everyone except his team. He ignored them completely that made it happen. And the people at Connaught Medical Research Laboratories that grew all the virus never mentioned a word. I would like to think it was a mistake. His laboratory people never forgave him. I mean, he spent time thanking everyone, except Sabin, of course. And a lot of scientists didn't like him because he had publicity. But on the plus side, they wanted him to patent this. And when he was asked who owns the patent, he responded, well, the people, I would say. There is no patent. Could you patent the sun? And so it never was patented. Also, perhaps a little bit more important, for him at least, was The March of Dimes funded the building of a major research institute in California called the Salk Foundation, and it is one of the premier research in medical research in the world. And so that was worth a lot more than his medals. Connaught Medical Research Laboratories, they make all of, at that time, they made all of the vaccines and drugs for Canada. They went on to be very successful, and they were bought a few years back by Sanofi, and they have a brand new campus up in Toronto where they do world-class research on drugs and monoclonal antibodies. Roosevelt loved Warm Springs, Georgia, and in 1932 he built this house, which became known as the Little White House. 6 rooms, it had a garage, servants' quarters. He paid about $8,000 for it. It was his favorite place. He would go down there every chance he had, which unfortunately was not many. He would take a train down there. He struggled with his paralysis his whole life. The news media never reported on it. There were very few pictures of him ever taken in a wheelchair or trying to walk. He died while this painting was literally being made. He was sitting for the painting, and he had a headache, went to bed, and died from a cerebral hemorrhage. He was elected president 4 times. And during his 12 years in office, it would have been 16, but he died a couple months after his 4th term started. He established the Civilian Conservation Corps, Tennessee Valley Authority, Securities and Exchange Commission, and Social Security system. And then, for the love of almost everyone, Republicans and Democrats, he repealed prohibition. You gotta love the guy. This is the Warm Springs Institute today, brand new, not brand new, but completely modernized. The Warm Springs, Georgia Foundation sold it to the government of Georgia for $1, and they have converted it into a major rehabilitation center for people with handicaps, not just from polio. And so that is part of his legacy. He spent 24 years of his life fighting his polio-related disability. He spent 19 years of his life helping others fight their polio problems at Warm Springs. He spent 8 years of his life leading the U.S. through the Depression, 5 years of his life fighting World War II. It was his last and his best fight. And March of Dimes, 10 years later, beat polio on the anniversary of his death. And ever since then, he has been on the dime since 1946. They issued it on the day of his death, anniversary of his death. He literally worked himself to death between the polio and a heart condition. World War II did a number on him. People don't realize it, but he traveled all over the world to meet with Churchill and Stalin on 4 or 5 occasions into combat zones, flying on the Pan American Clipper, US warships, and eventually a converted World War II bomber. His last trip, I believe, was in February to Yalta. Yalta is a small town on the Crimean Peninsula, which used to be the Ukraine until a few years ago. And there he met for the last time with Churchill and Stalin. And at that point, he was a very sick man. And trying to travel that way, you know, these are not pressurized planes he was flying in. He was they could have run into fighters. He had 2 meetings in Tehran. He had a meeting in Egypt. He had a meeting in Casablanca. These were not easy trips for a healthy person. And he couldn't walk. And so It really was very, very tough. So he does deserve a lot of credit. My interest in this is that this was the first commercial use of cell culture. And prior to that, it had been, people started growing cells in culture in the early 1900s. But it was so incredibly difficult to do. Very few people did it because they couldn't figure out at that point what it was good for. And it was so hard that most people didn't try it. And so along comes Enders, and he shows that you can make a vaccine. Salk did the vaccine, and that was the first product commercialized using cell culture. And today, this is a small reactor. It holds 1,500 liters. It's about 400 gallons. And that has cells in it, and they're producing virus. And that would produce as much virus in 4 or 5 days than they were able to produce in all of 1954. This is not a large fermenter. The largest fermenters are up in Portsmouth, New Hampshire. There's a company up there. They have them that run 20,000 liters. They look like silos. When you watch TV at night and they have all these wonder drugs that come on that cost, $5,000 a dose, those are all made in cell culture using Chinese hamster ovary cells to produce the products. You can buy, if you have an ulcer, you can buy skin, human skin, grown in cell culture that can be used to treat it. Started out as microbiological associates right around the time Enders was doing his work. And this all started with the Salk vaccine. These are some readings that are pretty interesting. I didn't mention, because of time, the Cutter incident. Are you familiar with the Cutter pharmaceutical company? How about Cutter insect repellent? There's a reason they're making insect repellent. They used to be one of the leading drug manufacturers. And when the polio vaccine was proven to work, there were 5 companies, drug companies, that were given license to produce the first batches outside the control of March of Dimes. And the batches Cutter produced hadn't been killed. Infected a lot of people, killed 10. And a couple of the other drug companies, they also had minor problems with quality control. That was covered up. And it wasn't that they were sloppy, they just were in over their heads. It was new. How do you do this? How you test it. And the US government didn't have an agency even to overwatch.
The FDA was.
The FDA was there, but the FDA had very, very little power to do anything. Even today, if a company is producing a deadly product, the FDA has to jump through hoops to get them to stop. They don't have a lot of power. And that affected things, but the problem was fixed. The government set up an agency, and the record ever since then has really been quite good. But it is a very good story, and it shows how, the government can work and get things done. So if you have any questions, this is a good time. I'm sorry I went a little bit later, but I would like to tell you one more story. I did get to meet Sabin and Salk when I was working at the research center up in Lake Placid. They hosted a meeting that occurs every 10 years among cell culture users. And the topic of this meeting, this was 1978, was they were trying to get permission from the US government, the departments, NIH and Department of Biologics, to use cell cultures that were not normal for making vaccines and other products. It turns out in cell culture, it's very hard to grow normal human cells. It's much easier to grow cancer cells. They're like weeds. But to grow normal human cells is difficult. They also worry about cancer cells having cancer viruses. The most famous cell line and the oldest human cell line is HeLa cells. And there have been books and documentaries made about that. I've grown tons of HeLa cells in my life. Because they're easy to grow, let's grow products in those. Well, it turns out the human papillomavirus is part of HeLa now. And so if you work at it, you can actually get live human papillomavirus, which causes cancer of the cervix, out of the HeLa cells. So you don't want to use them to make viral vaccines. And Jonas Salk and Sabin were at this meeting, and they were speaking at this meeting. And my job was to show the slides. And you have to realize it's one of the more difficult jobs is showing scientists slides. Because this is when they had the carousels, upside down, backwards, inside out, constantly. I was at a meeting one time where they were upside down, and the scientist tried to flip the projector over, but he hadn't put the lock in, and all of them fell out on the table. So I got to show the slides. Everyone that ran this, including some of the people I worked with, ran this meeting, were scared to death that there was going to be a big scene between Salk and Sabin. And the good news was they kept them apart, so it didn't happen. Salk got up and gave a talk bragging about how it was ridiculous to worry about injecting HeLa cells into people because he's injected HeLa cells into prisoners all over the country and none of them died. That's not something you want to say, even then. And the, pardon?
They were used as guinea pigs, obviously.
Yeah, the prisoners were traditionally, prisoners and orphans were the two sets of guinea pigs.
They have to give the consent. No.
Orphans can't, they're not old enough to. Prisoners, yeah, they have to give consent, but you're a prisoner. Can you really say, no, I'm not going to do it?
And the mentally challenged too.
And the mentally challenged. And that's not done anymore. And there's a lot to be said for that, you know, but so their presentations were bound into a book. And my copy of the book, all the sections that Salk talked about this were eliminated because it was such a stupid, incredibly stupid thing to say. But, you know, here we stand today. Vaccines work. Although the head of RFK Jr., he claims the polio vaccine, I saw the video of this, I couldn't believe it, has killed more people than it helped. How
He
he,
uses data, so where did
Pardon?
he uses data. He says,
No, he misinterprets the data.
oh, okay.
so besides the Cutter incident, the other reason they stopped using Salk's vaccine was they were using monkey cells. Monkeys contain a lot of viruses we don't have. One is called the simian virus 40, number 40. It's what they call a B virus. SV40 causes cancer. These monkeys' kidneys have it. And so they believe that the virus got into the vaccines, should have been inactivated, but maybe it wasn't. So he claims that all those people that got the polio vaccine, all of us, have gotten cancer and died from it. Now, it is scientifically proven that this virus causes cancer in hamsters. Just as poliovirus can't cause polio in hamsters or grow, SV40 can't cause cancer in human cells. They don't have the key to fit the lock. But he can go on TV and claim it. Tomorrow it would look the same way it looks today.
Well, what about
Until the next pandemic. And so COVID was a pandemic. The last time we had a pandemic even close to that was in 1918 to 1920 with the Great Flu. That, they believe, started at Fort Riley in Kansas,
which was
in
common?
pigs. Pigs.
Pigs, I'm sorry.
Pigs. And when those soldiers were sent to Europe, they stopped at Fort Drum to get ready. And Fort Drum had a bad outbreak of some illness. And then they were sent over to Europe. And when they'd get wounded, they'd come back, back and forth, and that's how it started. So it's clear we need vaccines. The COVID vaccine, the quickness with which that was accomplished is unbelievable. And it doesn't use viruses, doesn't use cells. It's basically a chemical product. And they're going to be able to use that technique for an incredible number of things. Assuming, right now, RFK Jr. stopped research on it. But, the bird flu we have going around, if you look around, there aren't a lot of birds around lately. The bird flu has killed billions. And birds typically, a lot of the flu viruses, they're in ducks in farms in China. The same farms have pigs. So a bird virus starts growing in pigs, it alters itself to grow in pigs. Pigs are awful close to humans. And then eventually one of the pigs has a mutation in the virus, it jumps to people, and you have a new epidemic. In the old days, if you look at the Black Death, it decimated cities in Europe in the 1600s. One of the reasons it didn't wipe out the world was we didn't have plane travel. We didn't have trains, we didn't have cars. Most people that lived in London never went further than 2 miles away. And so you might have terrible outbreaks in one area, but the rest of the world was unaffected. I'd like to thank you very much for coming.